Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the level 2 problems of current carrying wires creating some magnetic field. So in this level 2 problem, you can see simple. In the first problem that this is a circular coil which is divided into two parts. The one part has a radius r and the other part has a radius of r dash. So we have to find out the magnetic field at the center of this loop. Now obviously uh, we know that this angle is 3 pi by 4, in fact 3 pi by 2, and this angle is pi by 2. And we can say that the direction of magnetic field due to both of these arc will be same. So the magnetic field due to this arc will be mu naught I by 2r, and the angle is pi by 2 divided by 2 pi. So it would be let's suppose that magnetic field due to this one is B1. So B1 will be equal to mu naught I by 8r, and the direction is inside this plane. And B2 is the magnetic field due to the second wire, and B2 will be mu naught I by 2 r dash, and the angle is 3 pi by 2 upon 2 pi. So it would be mu naught I 3 mu naught I by 8 r dash, and again the direction of B2 will also be inside the plane. So the net magnetic field B will be mu naught I by 8, and this is 1 by r plus 3 by r dash. So the correct answer will be option number D. Now we move on the next question. In this question, you can see that there are two wires, one is this and one is this. This is not a current carrying wire CBAD, which is in shape of a semicircle. So this is not a current carrying wire, this is just a groove this is a shape of disc, and there are two grooves which are made on the surface of this semi disc, and in the grooves there are two wires like that. So we have to find out the magnetic field, net magnetic field due to these two wires at the point D. So for that, first of all, let us find out the net magnetic field due to wire AC. So for that, let us draw a perpendicular like that, and this angle will be 60, and this complete distance will be 2r, and it would be r. So the perpendicular distance will be r, and let us suppose that let us name the magnetic field as BAC. So BAC will be equal to mu naught I by 4 pi r. Now r is this distance obviously, and one angle of this wire is 0 degree, because this perpendicular is itself that line which is connecting this point with A. So we know that phi 1 or phi 2 are the angles between the line connecting the point and the wire end, and that angle is measured with the perpendicular. So if this perpendicular is itself that line which is connecting the end and this point D, then we can say that one angle will be 0 degree and the other angle will be 60 degree. You can see that this perpendicular is making an angle of 60 degree with this line which is connecting this point D with other end of the wire. So this is sine 60 degree, and the direction of magnetic field will be outside the plane dot. So BAC will be equal to mu naught root 3 mu naught I by 8 pi r outside the plane. and B due to CB, and the magnetic field due to CB will be inside the plane of the paper, and it would be equal to mu naught I by 4 pi. Now perpendicular distance from B to D is this one, and this angle will be 30. So perpendicular distance A, which is BD, will be 2r cos 30. So 2r cos 30 will be equal to root 3r. And the one angle is obviously 0 again, and the other angle is 30 degree. You can see. So sine 0 plus sine 30. And the direction will be cross. So BCB will be equal to mu naught I by 8 root 3 pi r, and the direction will be cross. Now you can see that BAC is greater than BCB, so B net will be equal to mu naught I by 8 pi r and root 3 minus 1 by root 3. So it would be equal to mu naught I by 4 root 3 pi r, and therefore the correct answer would be option B. Now let us move on the next question. In this question, you can see that this is a figure which is formed of squares, and these squares are carrying the current in alternatively opposite directions, which means that the smallest square is carrying the current in clockwise sense, then the other square, second square, is carrying it in anti-clockwise sense, and the third square is carrying in clockwise sense, and again fourth square is carrying in anti-clockwise sense. And these squares are constructed till infinity from all the sides. So we have to find out the net magnetic field at point O. Now first of all, let us find out the net magnetic field due to square on the center. So we know that the net magnetic field due to a square will be 4 times of the magnetic field due to this one wire, single wire. And if the side of the square is A, then this will be A by 2, and these angles will be 45 degree. So it would be mu naught I by, in fact we have to find out the magnetic field due to a square, then it would be 4 times of mu naught I by 4 pi A by 2 and sine 45 into 2. Okay, so cancelling this, and it would be equal to B of square will be equal to 2 root 2 mu naught I upon pi A. Okay, and this is due to one square. Now there are multiple squares which are carrying the current in alternatively opposite directions. So the magnetic field due to all of them will be in the opposite directions alternatively, and the sides of each square is different. You can see that the side of the smallest square is A, and the side length of the bigger square is 2A, and then it is 3A, and then it is 4A, and so on. So B net will be equal to 2 root 2 mu naught I upon pi, and it would be 1 by A minus 1 by 2A. Now this minus is due to the fact that the direction of magnetic fields due to the alternative squares is different. Then it would be plus 1 upon 3A, then it would be minus 1 upon 4A till infinity. And we know that this is the series of ln2. So B will be equal to 2 root 2 mu naught I by pi A ln2. So the correct answer will be option C. Now we move on the next question. In this problem, you can see that a thin insulated wire forms a plane spiral of 100 tight turns carrying a current of 8 milliampere each, and the radius of inner radius is 50 mm and the outer radius is 100 mm. We have to find out the magnetic field at the center and the magnetic moment of the spiral. So we know that first of all we have to consider a element. So this is the element, and let us suppose that the width of this element is dx and the radius of the element is x. Now we know that 100 turns are on the width of this section is b minus a. So let us suppose that b is equal to 2a because b is given as 100 mm. So b is equal to 2a. So width will be b minus a, which is a. So on single, or we can say that on width a there are 100 turns. On unit width there would be 100 by a turns, and on dx width the number of turns dn will be 100 by a into dx. Okay, and the magnetic field due to this small element will be dB at the center, and it would be mu naught ni, which is dn into I, divided by 2r. Now r is x, so dB will be equal to mu naught I, and dn is 100 by a into dx divided by 2x. And the net magnetic field will be the integration of this field, so it would be mu naught I by a, and this would be 50. Now we have already assumed that this a and dx are of same units, which is of mm, and therefore the integration of this would be equal to dx of integration of dx will be equal to integration of 1 by x will be equal to ln x. Okay, and we'll put the value of a afterwards. So the limit of ln x would be from a to 2a. So b will be equal to mu naught I into 50 upon 2, in fact upon a ln 2. So b will be equal to mu naught is 4 pi into 10 raised to power minus 7. I will be 8 into 10 raised to power minus 3. Number of turns is 50, and a is 50 into 10 raised to power minus 3. Okay, so cancelling this, ln 2. So b will be equal to 32 pi into 10 raised to power minus 7 ln 2, or we can say 8 mu naught ln 2. Okay, so this will be the value of magnetic field. And now if we have to find out the magnetic moment, then we can say that the small magnetic moment due to that element will be NIA. N is dN, I is the current flowing through this spiral, and A is the area bounded in the element, this complete area. So it would be pi x square. So it would be pi x square. So dm will be equal to dn, and dn is 100 by a dx. So it is 100 by a dx into I pi x square, integrating. M will be equal to 100 I pi by a x cube by 3, and the limit of x will be from a to 2a. So m will be equal to 100 I pi by 3, and it would be 8a cube minus a cube. So m will be equal to 100 I pi into 7a square by 3. So m will be equal to 100 into I, which is 8 milliampere. Pi is 22 by 7, and this is 7. A square will be equal to 2500 into 10 raised to power minus 6 divided by 3. So we can say that pi is 22 by 7. So this is 100 and this is 100. This is 10 to the power 4, and the power of 10 will be 10 to the power minus 5, and pi is 22 by 7, so it would be 8 into 22 into 25 by 3 into 10 raised to power minus 5. So this will be the answer. You can find out its exact value by calculations. So this will be the magnetic moment and this will be the magnetic field. Now let's move on the next question. In this question you can see that there was a square loop of side L, and this square loop is folded into two half parts, and each of the half part is connected in L shape like that, and O is the center of the frame, and this loop is containing a current of I. We have to find out the magnetic field at the center O. Now first of all, if we try to predict the correct answer by using the direction of magnetic field only, then we can say that the magnetic field due to this loop will be in the plus y direction. You can use the Fleming's right hand rule, screw rule, and the magnetic field due to this loop, this one, will be in plus x direction. So definitely option A will be incorrect and option B will be incorrect. So the correct option will be from these two options only. Now we have to also find out the magnetic field value at the O. So let us again use a square, and let us find out the magnetic field by this square at the center. So we know by using a concept that if we find out the magnetic field due to a single wire of the square, and if we multiply this magnetic field with 4, then there will be the magnetic field due to the complete square, and hence we can write it down as 4 times of mu naught I by 4 pi A. Now A in this case will be A by 2, and these two angles are 45, so it would be 2 sine 45. So this magnetic field B due to square will be equal to 2 root 2 mu naught I by pi A. Okay, now if we just draw the half part, or if we analyze this half part only, so let us name it as part 1 or rectangle 1 or part 1, and this part as part 2. So we can say that the net magnetic field due to square will be the sum of the magnetic fields due to these individual parts, and these individual parts will be creating a magnetic field of same magnitude and same direction at point O. So we can say that twice of the magnetic field due to one part. I have assumed that the magnetic field due to this half square at point O is B. So I can say that the magnetic field due to this complete square will be 2B. So 2B will be equal to 2 root 2 mu naught I by pi A, and B will be equal to mu naught or root 2 mu naught I by pi A, which means that the magnetic field due to each of the half part will be root 2 mu naught I by pi A, where A is L in this case. So the correct answer will be option C. Now let us move on the next question. In this question you can see that there are 3 wires. One is this one, which is parallel to y-axis, and it is carrying a current I in the positive y direction, and this one is the wire in the plane of xz, and this is the wire like going like that. So we have to find out the magnetic field at origin due to these three wires. So we can say that if we first of all name the wires, that it is 1, it is 2 and it is 3. So we can say that magnetic field due to 2 and magnetic field due to 3 at point O will be 0, because O point lies on the axis of these wires, and the magnetic field due to wire 1 will be calculated. So let us draw the top view. From the top we'll be watching the XZ plane, and wire will be taking the current out of this plane. This distance will be equal to root 2a, and you can see that this wire is coming from infinity, but it is terminated in this plane, which means that one angle is 0 and one angle is 90. We have discussed this fact many times, so I do not need to repeat this again and again. So B net will be like that, and B net will be in the minus x direction, as well as in fact minus x direction and plus z direction. So obviously we can say that answer would be C, but let us also calculate the value of B. So the value of B will be mu naught I by 4 pi A. Now A will be root 2A, and if we take the components of this B in the Z and in X, so it would be BZ will be equal to B by root 2, and BX in the backward direction will be equal to B by root 2, and B by root 2 is mu naught I by 8 pi A. So the answer would be C. Now let us move on the next question. In this question, you can see that there are three infinitely current carrying conductors which are placed like that. This is the first one, this is the second one, and this is the third one. These two wires are carrying a current I, same current, and the third wire is having some unknown current which we do not know. Now these three wires do not intersect, and we have to find out the net magnetic field related options, correct options for point P. So let us first of all see that the direction of magnetic field due to these two wires is outside the plane at point P, and the direction of magnetic field due to these two wires is also outside the plane. Okay, so the magnetic field, net magnetic field at P due to these two wires is non-zero, and we do not know the magnitude and the direction of current flowing in the third wire. So we cannot say that the net magnetic field at P is 0 for all values of x. Okay, first of all. So if the current flowing in the third wire is 2I by sine alpha, then the net magnetic field will be 0 at P for all values of x. So let us examine this case. We can see that this wire is carrying some current I, and this wire is also continuing this current to infinity. So we can say that we can consider these two wires as a single wire, and this single infinitely long wire will be creating some magnetic field at point P, and that magnetic field B1 will be equal to mu naught I by this is x, and this will be x sine alpha. So mu naught I by 2 pi x sine alpha, and this 2 pi is due to the fact that there will be sine 90 plus sine 90, and sine 90 plus sine 90 will be 2. So I've already cancelled that 2 with this 4. So this will be the B1, and B1 is the net magnetic field due to both of them. Okay, and B2 will be the net magnetic field due to both of them. So it would be equal to B2. So B net will be equal to mu naught I by pi x sine alpha. This will be the net magnetic field. And if we consider this third wire, you can see that if this third wire, this magnetic field is outside the plane. So to cancel this magnetic field, this third wire should have a current flowing from this side to this side, which means from right to left. Okay, so we can say that due to the third wire, and the magnetic field will be mu naught I by 2 pi x, and it would be equal to mu naught I by pi x sine alpha, and if these are equal, then net magnetic field at P will be 0. So cancelling mu naught with mu naught, pi with pi, and small I will be equal to 2I divided by sine alpha, and cancelling x with x. So B option will be correct, because for all values of x, the net magnetic field will be cancelled out at point P. Okay, and the current should flow from right to left. Okay, first of all, right to left. So C option would be correct. Okay, now let us move on the next question.